Welcome back to AI for Cybersecurity. Our next speaker is Roehm. He's the CEO of APHERIS. Please join me in welcoming him to our virtual stage.
Thank you so much for the introduction, and I'm very excited to be here. I'll directly start sharing my screen before I jump into the topic. Fantastic. So maybe I start the session with a quick intro on myself and the idea of how we came up with founding the company and how we empower different companies to jointly analyze data across organizations while keeping proprietary information private. So I have a background in medicine and mathematics, and my first real venture-backed company that I founded was called Janus Genomics. And with that company, we developed software tools to make the life of biologists more easy when they were trying to build machine learning applications on genomics data. And so we built a first product and shipped it to pharma companies and genetic companies. And the feedback that we received was detrimental, because even though the usability of those tools was quite nice, the companies couldn't use these tools because the data input that they needed in order to use our tools, this data input was distributed within their companies across departments. And due to regulatory constraints, these different departments couldn't share their data. And so that was the first time when we ran across the problem of distributed data that couldn't be shared due to regulatory constraints. And we later learned that even more often, companies or departments or organizations cannot centralize their data, not just due to regulatory or compliance reasons, but as well due to fear of losing intellectual property. And so when we ran across this problem, me and my co-founder, we sat down and wanted to solve it. And so in the end, we ended up building a solution for this very specific use case. And later on, feed forward another year, we founded a new company with the mission to empower organizations to securely analyze data across organizations while keeping proprietary information private. And so that's the topic of today. And I'll be guiding you why this is relevant and how effectively this can be done without sharing sensitive data or losing intellectual property. So maybe we start this presentation by looking at why this is even relevant. But before we do so, maybe a quick background on the company. So as mentioned, we empower organizations to securely analyze data across organizations without sharing that sensitive data. And we are basically fundamentally changing how companies can start to think about data and data value, because suddenly the use cases as a company you can think of are not just within, but as well outside of your organizations. The company is backed by first league investors across Europe and the US, and we have a close commitment to several open source initiatives and partner with leading customers and companies across very different sectors, starting within pharma companies, automotive, manufacturing, but as well companies like the Boston Consulting Group. Let's jump in and look at why data sharing across organizations is relevant. So when we look at how data is being captured or secured today, we see that almost always data is fragmented across different institutions. And these institutions typically can or don't want to share their data. Either the data must be protected due to compliance or regulation reasons, or the data is just incredibly valuable, and so institutions don't want to share that data as they fear losing their intellectual property or the trade secrets that this data contains. And this is true for almost any industry. So here are just 3 examples that we can quickly touch upon. So manufacturing, where data is basically the lifeblood of the future factory, and advanced analytics and AI get increasingly deployed, but trade secrets of the manufacturers prevent a data exchange across organizations. Then second example, molecular R&D, so drug discovery or material sciences. So I think everyone has seen this year what it is possible if pharma and healthcare companies start to collaborate on a global scale. But the time from developing vaccines has been shortened to a year from typically more than 10 years. And that has basically been due to joint research, due to data sharing activities that we have seen during this global pandemic. But as everyone knows, this is not the status quo, because individual molecules can be patented towards multi-billion-dollar products. And so here we have just incredibly valuable data where different companies don't want to share their data. And then last example, military or defense and space. I think everyone knows how complex it is to handle the sensitive data and exchange within and between allies. And so that's not an easy task, where definitely data sharing would allow you to produce better results. But again, regulation and fear of losing sensitive data prevent companies from, or organizations from, sharing such sensitive data. So there is an opportunity that makes data sharing across such organizations possible. And that's basically due to advancements of two technologies that I will touch upon in a second. So the key opportunity is that institutions can get controlled access to the right data that is locked down in third-party companies without ever centralizing or sharing the sensitive data. And we can take a look at how this can work. So two breakthrough technologies are really driving this change. That's on the one hand, federation, and on the other hand, privacy-preserving computations. So for federation, the key idea is, instead of centralizing the data at one place, what you do is you bring the computational request to the different data sets. So federated machine learning would mean you have different data sets in different companies, and you would bring the computation requests, in that case, an untrained AI model, train it locally there, and organize only the exchange of updated local parameter updates of the machine learning model with and between the different companies. So that's the idea of federation. And then the second idea is the idea of privacy-preserving computations. And here, the key fundamental innovation has been that privacy is no longer a property of data, where you would think of, when you think of anonymizing data, there you treat privacy as a property of data, but rather newer technologies treat privacy as a property of an algorithm, a function. And so different techniques, starting from cryptography and ending in statistical privacy technologies, can help here, driving the change that if you compute in a federated manner, meaning bringing computations to the data, and then make sure that those computations are privacy preserving by design, meaning they only produce results that are private, that if those two work closely aligned, you can start to think about analyzing data that is locked down in different companies without ever sharing that data, and while being sure that intellectual property and privacy is preserved throughout the entire computational workflow. And so that's basically what we as APHERIS empower, and what our core product and our core mission is. So what we want to do is we want to help a company to perform their analysis on distributed data of multiple third-party companies in a completely secure and private manner. And how that works, I can quickly guide you on that. So let's say a data scientist in a given company wants to train an AI model in our example, but could be any computation on data of multiple organizations. What he would do is he would send his computation request to what we call here privacy guard or privacy layer. Then with such privacy preserving technologies, we would advance or extend this computational request with certain technologies to be privacy preserving by design, and then distribute it to the different data owners. Then training would happen locally in their environment, so no data would be moved. And then a central aggregator would coordinate the information sent between these different parties, and such that if the global model would converge, that would then be handed back to the data scientist who would never have touched the individual data sets, would have no chance to reconstruct the underlying data points. And nevertheless, the model that has been trained would have consumed information and have learned on all those different data sets. We can as well take a quick look at, let's say, the inner workings of such a product. So here let's say, more granular picture of the same of what we've seen before, just with one party at the other end. So what we would do is we would offer the data scientist a virtual environment where he can sketch his computation requests. So basically that's a reference data set that resembles the original data set, where he can start drafting what he wants to compute. Then he would send his computation request or upload his computation request via an API to our privacy and auditability guard. We would first of all measure the potential leakage, so test certain attacks against this computation request, and then add exactly the measures that preserve the utility of this computation request, then Dockerize it and launch it in a secure and confidential environment where the data owner hosts his data, that's under his control, no data is moved, and we as APHERIS as well would not have access to such data. And then once training has happened, the computation output, so not the data, the computation output would be shared back with the data scientist, and this computation output is by construction privacy preserving. And this again was the workflow once through the product, but you can think of such a workflow between multiple companies and iteratively run across such a setup with multiple data owners in place. And so in the end, as such, you can as well think of federated computations, allowing multiple organizations to jointly analyze their data. So that is how, in general, the idea of federated computations and privacy preserving computations work together to build such, to allow or to build a foundation on top of which companies can think of data ecosystems. And and that is basically what we see across industries, how much change and what a different perception of value companies can start thinking of when the value of data is not just bound towards what can be unlocked within their own organizations, but as well for use cases outside of their organizations. And so what we see is companies building data ecosystems across institutions. I'll touch upon that in a second as well. Then what we see is the idea of federated edge-based analytics. So when you want to collectively analyze data at the edge without storing it centrally, again, I can show a couple of use cases in a second. But as well, what is changing is the idea of data ownership, and the way we think about data protection gets fundamentally changed, because in such a federated model, you can make sure that all information that is exchanged between institutions is always anonymous and secure by construction. So basically, you can start training models on sensitive data of multiple institutions that would, as well from a regulatory perspective, initially not be allowed to pool their data due to regulatory constraints, because all the information that leaves a local institution is constructed in a manner that the information that is contained, that is sent across, this information would never allow you to reconstruct individual data points. And so, yeah, regulatory bodies like GDPR would not apply to such a circumstance, and therefore allow companies to build joint models on their data without pooling it initially. So these are basically the new ideas and new movements that we see in various industries by allowing companies to unlock the value of federated and privacy preserving computations. And so when we look at exemplary use cases, they are very broad, and as mentioned, we operate in many different industries, but we see that in particular R&D and innovation is often driven by the idea of collaboration across institutions, across departments. And so what we can think of is, for example, industrial AI in manufacturing. So think of predictive maintenance systems that need high quality data and diverse data of multiple manufacturers to properly learn, But as mentioned initially, this data is typically valuable. It contains trade secrets, and so manufacturers cannot share it. But with the idea of federated machine learning and privacy-preserving machine learning, multiple manufacturers can start jointly learning predictive maintenance systems, and thereby learning from as well different units, such that model generalize better, and therefore the runtime is increased heavily. So that's one of the use cases that we see. Then when we think of material sciences, so in pharma and general material sciences, the key idea is often to learn models that predict the property of molecules better. And obviously, in particular, in such such sciences where you have a huge amount of possible data, so the chemical space of, for example, drug-like molecules is 10 to the power of 60 or even more. So incredibly large potential space, and what we have in terms of data being available is just a tiny portion of it. And so the key goal must always be to learn on this smaller data sets towards models that generalize. And so in order to do that, we need models that have seen a broad applicability domain, that have seen a broad a diverse set of data points to really learn what it takes to extrapolate the findings towards new biochemical space. And so that is being made possible if multiple pharma companies, for example, start sharing their data, jointly learning data to predict the property of given molecules, and as such build a data ecosystem for exactly such applications. And so that's one of the examples where as well APHERIS supports with and builds the foundation. Then if you think of supply chain and logistics, so here again, data is typically distributed across many different companies, and in order to receive a view on the entire value chain, you obviously need to make sure that data is always secure and private at any given point in time. But if you do, you can really think about optimizing that. So starting from inventory management, but as well lifecycle management would be suddenly transformed if you could get a complete view on data of multiple parties. So here again, a huge value driver where data sharing is fundamentally changing how companies can build data products, can interact with data, can think about optimizing their businesses. Then aircraft industry, similar to basically predictive maintenance, is one of the key ideas here to get active, but as well condition monitoring systems. And then, typical use case, unmanned aerial vehicles, so drones. Lots of sensor and image data is captured, but this is typically sensitive. And so if you think of building Internet of Vehicle components, such that data can be collectively analyzed across institutions that host such systems. So it's incredibly important that as well the national regulations are taken care of. And so basically here introducing the idea of data sharing will have a profound impact, not just on ideas like traffic prediction, but as well when it comes to surveillance systems, or pretty much any portion of our lives that get influenced by such technologies. Then again, I quickly mentioned military at the beginning, so defense and space, how you produce things as well, how you collaborate across allies. I think, typical applications where we see, use cases across different institutions that drive value and that help make the production more reliable. And then last but not least, definitely cybersecurity. So if you think of anomaly detection, data is typically distributed, and joint analysis would tremendously help all different participants. But often this data is super sensitive and can't be shared. And so companies would need high volume of data to be successful, but that is distributed. And so again, federated and privacy preserving machine learning can help here train models across these different institutions to build a global a global detection system that outperforms all individual ones that you could build. Yeah, so that is basically the key insights on use cases. And then before I end, maybe a quick words on how this changes how companies think of value and value generation. So obviously in data ecosystems, the value of your data is not bound to the value that companies can create with it within their organizations, but suddenly the use cases outside of the organizations and as well with complementary data of other organizations become much more valuable. And so the value of data can be increased heavily by thinking about how to unlock value for different customers with complementary data being accessible. And so that's basically as well what we as APHERIS support with. So if you have any ideas on why this could be relevant for your business, or any interests in learning more about the solutions, the technology, feel free to reach out to me. Here below at the bottom is my mail, and I'm happy to answer questions and help you on how to think about data and data value in such distributed setups. So with that, I would end, and happy to take any questions or comments, or otherwise as well follow up offline later.
Awesome. Thank you so much, Roehm. Thank you for sharing with us. We really appreciate these insights. All right, for the audience, it's time for you to head to your next session. So you can go ahead and make your way there. Along the way, you can also connect with our sponsors, check your connection request, and do some virtual networking. Thanks so much, and we'll see you around.